Welcome to the end of day 2.
Yes, welcome.
Let's kick it off with some lightning talks, shall we?
We shall. As a reminder, each of our speakers will get 5 minutes. When we get down to around 20 seconds, we'll start with our small claps, 1, then 2, and then we'll go into a full clap to let our lovely speakers know they are at time. So let's go ahead and start with our first speaker, Christian.
Hello, can you hear me? Yeah, cool. Okay, so I will do some live coding, so maybe everything will explode, but let's see. Hola, bonjour, hola, hello, ciao. We know languages are beautiful, but sometimes they can be a barrier. My name is Christian. I'm going to talk to you about Python and Espanol, so you can follow me there on social media, whatever, but this is not relevant now. So, how many non-native English speakers do we have here in the audience? A few. Okay, fair enough. So for us, usually learning to code requires learning English, which is not bad, but of course is an extra step. So I was thinking, okay, how can I put this in perspective for people to understand kind of like the things that we need to do, right? So since I like to play a little bit about with CPython, so I was thinking of doing something maybe silly. So let's start with a simple Python interpreter. Nothing wrong there, pretty sure that everything makes sense. So the first thing that I learned in the Python were a lista. So you can create a lista with many elements, with many elements there. And this was really cool because I came from Bash and Perl, so okay, lista is cool. But then you can, of course, create it in a more simpler way. And how can you populate a lista? Well, you can use the famous mientras loop. So you can go and say like, let's try with a contador. And mientras contador is less than 10, you can go and do an adjuntar and then increase the contador by 1. And then you have lista. Well, by the way, if you don't know about this adjuntar thing, you can always, of course, do the ayuda. And you can get that, adjunta el objeto al final de la lista. Okay, so, but the cool thing about Python when I just learned it was the really famous para loop, okay? So if you want to start maybe populating another list, you can use the para loop. So, para ítem en L, you can do L2 adjuntar the item, and then you have the same thing. You can, of course, make sure that these things are the same with the typical afirmar, of course. That, okay, they are the same. Another thing to do the whole loop stuff was with ranges, right? So you can, let's create another one, and then you can do the typical para y en el rango de largo de L. You can go there and get the item by L and I, and then the typical adjuntar method that you already learned, right? And then you have this thing. Be careful with ranges, though, because if you access a range, sometimes if the item doesn't exist, then you will get an exception, right? So how do we handle exceptions in Python? With the typical intentar excepción. So if you go intentar, and you go, for example, something crazy, like, I don't know, 99, you can capture the excepción, and then typically imprimir something. Oh no, right? Okay, so of course this thing was just playing around with the CPython code. I mean, I just butchered everything with the grammar, nothing too serious, but yeah, maybe I should get another hobby. So let's go to the solutions. I know this is not the solution. I don't expect Python to be in Spanish, of course, at any moment, but we could help differently. So maybe you can start your projects having in mind that at some point someone will really keen into maybe translate the documentation, all the README and all the things that you have. And we can see this, for example, in this effort that started in Python Argentina, that they started to translate a tutorial from Python. Then it transformed into the whole group translating the official documentation of Python. And we finally have it there since a couple of months, well, maybe a year. On other things, like, for example, las Pycon charlas, that is usually an instance that help us, of course, to be around people that speak the same language, and, you know, learning in your own language will make you feel home. So at least from the Spanish community point of view, we started to do something like that, and this is Python en Espanol. You can check the information there in hablemospython.dev. You will not find the Python interpreter in Spanish there as well, but because that's not the goal. But if you don't speak English as a first language, maybe you can start your own communities just to encourage and enable, as Peter was saying in the keynote, to enable more people, to have more developers, and what else that learning in your own language. That's it. Thank you very much.
What a great talk. I'm so glad we're not changing very much between Python 3 and Python 4. All right, next up we have Mario with My First PyCon Reflections. Give it away for Mario.
Hi, everyone. This is My First PyCon Reflections. Yes. Again, I'm Mario. You can find me on Twitter, Python by Night. So my journey to PyCon began with a call to adventure. It was actually this tweet by the Pycon Twitter handle with a call for proposals. And I thought to myself, why not? It can't be that hard, right? And I was surprised in early February when I guess it wasn't that hard. I got my tutorial proposal accepted. So that just meant that I had to have a bit of help to get to PyCon, some supernatural aid. And that was in the form of the travel grant. Thanks, PSF. Thank you very much. Yes. So to cross that threshold and make the journey, my family and I had to make the journey from Redlands, California, up to the Salt Palace Convention Center. It was a little over 9-hour drive. We thought to do it in 2 days, since my 3-year-old daughter probably couldn't handle that drive. We stopped at a place called the Valley of Fire in Nevada, where I saw some cool cave paintings, petrographs, I guess they're called, over 4,000 years old. This is me in my best caveman cosplay. You may see my daughter there in the middle of that one, this Martian landscape, my wife there trekking through Mars, apparently. And eventually we arrived. The next day I was ready to go. This is me at the entrance of the convention center. Yes, I chose the silly pose, of course. My wife will not like that. And then I was ready to enter the belly of the whale to tackle my tutorial titled Goodbye Hello World, Hello Functional Fast API Web App. Check it out on the video if you weren't there. Of course, the first thing to do is to make sure it was real. I was there in the middle of that schedule, so I began to get ready. This is me preparing for battle, looking through my slides. And then I went ahead and delivered this tutorial 1:30 p.m. on Wednesday. It was awesome. My preparation paid off. Again, I invite you to check it out when all this is said and done. Along my journey, I've met some allies, some enemies. No, not enemies. This is PyCon. Just allies. Some wonderful people I've met. Here we see Lauren, Chris, Deborah at the PSF booth. I helped set up, volunteered for that. I met Marietta. That was really awesome. I met a couple cool guys, and here's me awkwardly posing with them, Anthony and Jay. I don't know who this guy is, but he just wanted to take a picture. I'm just kidding, Peter. Sorry. So then I had a big ordeal. I wanted to get really involved. I started volunteering. I did some session running and chairing. That was really cool. I didn't realize that session running meant a lot of running. That's my steps yesterday, 11.98 kilometers. Then the supreme ordeal came while I was playing a wonderful game of exploding kittens. Now, what could that supreme ordeal be? Well, that was that my lightning talk got accepted. And I was like, oh boy, now what do I do? So I had to prepare, furiously putting slides together. But here I am, enjoying every bit of PyCon as much as I can. You know, this journey, it's been great. It's been awesome. I've loved it. And it's not all for nothing. There's wonderful bounty to be had. Here's just a slight bit of stuff that I've gotten. So it's pretty great. I'm sure some of you have even greater bounty. But I was really happy because you can barely see on there. I got the last metal straws that they were handing out at one of those booths. Really cool thing. All right, so that's been my journey so far. I know that pretty soon it's going to be time for the road back, time to head home. Not sure how I'm going to do that. At best, I'll just follow the signs. And I hope to see all of you again in 1 year at the next PyCon. Thank you.
I think, Mario, you have had a very eventful first PyCon.
Next up, we have Georgi, who's going to talk to us about how open source is the walk in the park. But real quick, I want to give a shout out to Georgi, because Georgi did all of the beautiful graphics that you see for PyCon in the new PSF annual report, which just came out. She did all those as well, and they are terrific. So let's give her a round of applause. Go ahead.
I like how the captions spell my name. Well, hi everyone. I have no slides, so you can just concentrate on me. So, how many of you like to take a walk in the park? How many of you like to walk in a paid park? No, expensive, right? Well, a free park, yeah, why not? So open source is like a community park. It's free. Anyone can just walk in there, enjoy the nature, enjoy the birds. You use all the facilities there and do whatever you want. Not everything. I don't know. There's a limit. There's a limit. So there's always something magical happening when you spend your time outside and you get to share your time with people and to interact with people. But it requires maintenance. You need to clear the fallen leaves. You need to clear the garbages. And sometimes you have people who started doing some graffitis here and there. And or you need to trim the plants and the trees. So why do I say that open source is like a park? Because it's free. You are free to go. You can do anything you want, but you still need maintenance. Contributors are like people like you and me. We can always walk in the park, but if we are the person who actually create and throw the rubbish, someone else needs to clear it. And if you want to be a contributor, to be a nice, really great contributor, make the park nicer, you help to pick the garbages. You can help to remove the graffiti. You can help to create more space. Sometimes you have really cool companies coming in and say, hey, I would like to make a donation. I would like to help. And how about I create a bridge and make this place nicer? A playground for the kids. Or some benches. And yeah, of course, when you have all this coming in, the community park will look more beautiful, will look more sustainable. The next time when you come back, you can use it again. It will look more beautiful as compared to a community park that has not been maintained. So if I'm not going to spend the entire 5 minutes, so if another lightning talk wasn't come up, feel free. Anyway, so if you want to contribute, you want to have a beautiful park, start improving this open source community and do something, whether you're a company or whether you're a contributor. That's it. Thank you.
Thanks, Georgi. Hey, Lorena, you sticking around?
Unfortunately, I have to leave. I'm an auctioneer for the PyLadies auction tonight, so I'm actually going to be heading out. Quick plug, the PyLadies auction is today, so maybe I'll see some of you there.
I'll be there, but only after the lightning talks are finished.
Exactly.
All right. So next up, we have Bence, who's going to give us a talk on lint your playlist and fashion. Let's give it up for Bence.
All right. Hi, everyone. I'm actually here for the gymnastics thing, so I'm not sure what... No, I'm just kidding. I need to just give you like 1 minute of real quick context, and then we can get to the fun parts. I work on this project called SamGraph, and you need to know just like 3 things. First of all, it's like this tool. You get to write like a code search pattern, sort of like regex. It looks through your code and finds occurrences of whatever you were searching for. So here, we type logging.info ... and it's just going to find like all occurrences of this call, even if the developers are trying to be sneaky, and they all get highlighted. Second, you can write not only one pattern, you can write multiple, and you can combine them with logic operators. So for instance, here, we are looking at logging calls. You can read the left side of the screen line by line. So whenever inside the logging call there is a getenv, and the env has secret in the name, well, you shouldn't be printing that probably because it's secret, and so SamGraph will flag it for you. Third thing, it's not only Python, it works on many languages, and what we need to have fun is JSON, and this is the first time anyone ever said that. Okay, so now the actual talk. I know that my code is messed up, but I've recently been wondering, maybe the world is more messed up. So we're just going to make this assumption for the rest of this talk. And so then, how is it that we have linters for my code, but not the world? It just feels unfair, right? So I created Super SamGraph. This is basically a wrapper around SamGraph that just like abuses it, but also lints the world. So that's good. And now what I mean is whenever there's something in the world, you can like sort of translate it, represent it in JSON. Here's what I mean. There's this thing out there in the world. It's one of our GitHub projects. Something is wrong with it. I challenge you to find what it is. But no, as humans, we cannot really do that. So I'm going to translate it to JSON, because computers can look through it pretty easily. They will see something is funky. And specifically, the rule I wrote for this specific case is if we get a JSON object from the GitHub API that says we have a repository where the star count of the repository is over 100, so it's kind of a popular project, then it's kind of a problem if it doesn't have a code of conduct. So if we run SamGraph, it's going to output exactly this. Hey, you have this project in your organization, quite popular, no code of conduct, fix it. OK, now this sort of eased you into the concept. Here come the actual fun stuff. Spotify playlist. What is wrong with this playlist? I'll give you a couple seconds. You're not going to know, by the way. Spoiler alert. Some people say that it has Taylor Swift in it, and to those people I say, broaden your horizons. The actual issue is, you know what? I shouldn't spoil it. I can do a live demo. So this is a rule I wrote for Spotify, and it's going to prompt me to input a playlist ID. The issue with the playlist was that the tempo changes too much between 2 songs. So Shake It Off, going right into Smells Like Teen Spirit is too much of a change, over 20%. You shouldn't do that, I guess. The way it works is this linter rule. So we look at consecutive tracks, we extract the tempo, and we just like, do some math. OK, and the last one. One of the SamGraph maintainers visited me in Greece earlier, something like a year ago. This is a picture of us in front of the Greek parliament. And there is something wrong with this picture. Yet another challenge. What is wrong with this picture? OK, I'm just going to run SamGraph on it. You know what? Maybe I'm going to help you out a little. This is the JSON representation after running it through Google Cloud Vision API and some post-processing. OK, let's see what SamGraph has to say. We found a Greek fashion police violation. You're not supposed to go out in pants in the Mediterranean. The way this works is Google recognized the Greek parliament, told us what the latitude of the Greek parliament is, and then we can just look whether there's like a person somewhere in the picture, and there's pants inside the person. I guess that's how computers think. But yeah, that's basically it.
That was awesome. That is so cool. Thanks for that. Next, we have Mark, who's going to tell us about how you can help speed up Python with benchmarks. Give it up for Mark.
Okay, I'll see if I can get this over before Larry is set up, just to upset him. Okay, I'm Mark Shannon. I work with a Faster C Python team, and I'm here to ask you a favor. So, I'm often asked how much faster is C Python going to be, 3.11 going to be than 3.10? And I'm an honest person, so I always say it depends. I realize that's a somewhat unsatisfying answer, but it's the true one. And the reason we don't really know is because we don't know what your workload is. We don't know what you're using Python for. We have a bunch of benchmarks. They're kind of the standard Python benchmarks, but they're sort of a bit of an historical oddity. And there's also quite a wide range of results. It doesn't really allow us to tell you very much about how much faster your program is going to be. So we have Delta Blue, which is twice as fast, and Telco, which is no faster. Does your application resemble something that does lots of numerical processing, or does it do some constraint solving? So basically, what we need is you to help. I know I know about how to make a Python virtual machine faster, but I don't know a great deal about web apps or machine learning or whatever other thing you do with Python. There's 1,000,001 things that people use Python for. We would like to make your program faster in 3.12, but we can't do that unless we know what your program does or have some representative sort of version of it. And that's where you can help. I think this is the last slide. Yeah, this is a very short talk. So there's a benchmark website called PyPerformance that you can read on Read Docs here. It's on GitHub. That's the sort of application, that's a framework for doing benchmarking. It also holds a sort of standard benchmark suite. But you can run your benchmarks on it. So even if you don't have like a ready-made benchmark, you can at least like try and encapsulate your software. Even if it's proprietary or there's confidential information in it, you could maybe run it locally and at least let us know what sort of results you have. Yeah, the website's here. It's PyPerformance, read the docs, and then the GitHub thing. And if you need help doing that, or you have suggestions or sort of benchmarks you think we should add, even if you can't add a benchmark, but you think there's a domain in which we're obviously missing stuff, then let us know. And then you can, if you go to GitHub, faster C Python/ideas, there's a whole bunch of ideas on people how to make it faster, but there's also any ideas that are welcome on benchmarking or anything like that. So yeah, we need your help. We can't come up with benchmarks for domains that we just don't understand or aren't experts in, but you can. So that's it.
Thanks, Mark. What y'all didn't just see was happening while Mark was speaking was Larry restarted his laptop to get the monitor to work, and it worked just right before Mark finished his talk. So it was perfect, absolutely perfect. So next, Larry is going to talk to us about correlating your data with Correlate. Let's give him a round of applause.
Thanks. I watch the IT crowd too. So I have a problem. I like old-time radio, like the radio dramas from the 40s, like detective shows and westerns, but I hate bad file names. If you go onto the internet and download a big zip file containing, like, let's say, Boston Blackie, these file names are crap. However, you can get very nice, clean data, metadata about the old show if you go onto Wikipedia, or in this case, an episode log thing. So I'd like to rename all of those MP3s and give them nice, proper, readable names. But I have a lot of work to do. There are 199 episodes of Boston Blackie. There's 446 of Gunsmoke. There's 809 of yours truly, Johnny Dollar. And what if they came out with a new zip file and they update things? Now I have to do all that by hand. So I have more problems. I'm really lazy. I don't want to do this by hand. Also, it turns out I'm bad at CS because apparently nobody has solved this problem in a general way before. I know, I looked on Google. I guess I'm bad at that too. I will point out this is not the Gale-Shapley stable marriage problem. It's a slightly different problem. But the basic idea is I have two sets of data. Conceptually, they represent the same things, and I want to match them up together. How do I do that? So I wrote it. It's called Correlate, and I'm going to walk you through. I knocked together this sample code this afternoon to write this lightning talk. I basically took the list of the MP3s, and I took the list of all the episodes that I scraped off of a web page somewhere. So I import Correlate. I create my correlator object. I split out the two data sets. That's where you're going to put in all of your data. Here's the MP3s. Here's the episodes. This parses the MP3 file names and pulls out the date and the title. This parses the list of episodes and pulls out the title and the date and the star. The important lines are these. We're saying, here's a key, something interesting about this metadata, about this value, and that matches to this one. So this MP3 file, here's the date, or here is, the best way to do it is take the words of the title and lowercase them and send them in separately. So I do that for both the MP3s and the episode. It's a good idea to make sure that the data that's going in is actually what you intended. So there's a print thing. You can say print out my data sets. And this looks correct. I'm getting proper dates. I'm getting proper keys, both for data set A and data set B. And so I run it. You just run Correlate. This is the feature I'll tell you about in a second. And you just print out the results. And a fifth of a second later, it has correlated the 200 elements from this and the 200 elements in that and matched them together. And the results look great. It's doing a perfect job. What's really interesting is you've scanned through the results a little bit. This one, there are no words in common between the two titles, but the dates were the same, so it said, oh, those are a match. This one didn't have a date at all, like both sides the date was invalid, but there were a couple of words that matched out of the title, John Davis, and those were unique enough that Correlate said, oh, that's a good match. So Correlate features, you can weight the individual mappings of keys to values. You can have redundant keys, and you might think that was not helpful, but it's actually very helpful. If the word "the" matches 3 times to these two values, those are probably a good match. I support ranking, or what you probably think of ordering. I called it ranking. So like if 2 values at the top of the data sets seem like a good match, that might be better than one at the top and one at the bottom. And I support fuzzy keys, which slows everything down, but sometimes you just need fuzzy keys. So you can install it right now on pip. You can also look at the source on GitHub. It's open source. I'm done. Thank you.
Thank you, Larry. I think I understand Correlate now. It is magic. Cool. Thanks for that talk. And next we have Rich to give us a talk on the importance of effective, concise communication. Give it up for Rich.
Hello, everyone. I'm Rich Taggart, and I'm a software developer. If I had to describe myself in one word, I would probably say that I'm a skier. I spend as much time as I can in the snow and in the mountains. A word that I would not use to describe myself is brevity. If you were to ask any of my friends, they would probably tell you that I'm long-winded and I have a tendency to ramble about whatever it is that comes to my mind without any filter, especially in situations where I might be nervous for some reason. So, as it turns out, that ended up spilling over into my writing and my technical writing, so I thought I would share with you some things that I've learned as I've tried to improve that. Identify and convey the most important idea when you communicate with another person. This will allow you to achieve the greatest effect for your intent and effort. In today's world, we wish to spend our energy on more activities than we have time for. Various distractions pull our attention in many facets of our life. Allow your recipient to interpret your message with as little energy as possible. I've included here some tips to consider when composing a message. First, write down the topics, ideas, and thoughts you wish to send. Then, identify the common theme between these thoughts. Last, convey that main idea with one or two brief supporting examples. And this does not need to be a long, extensive process. Most of the time it takes a few seconds to jot down ideas, or maybe a couple minutes depending on the message. If you're not sure where to get started, I've found the Hemingway editor to be a great tool to help learn how to do this. That's my talk. Thanks, everyone.
Thanks, Rich. And next we have Sebastian, who's going to talk to us about testing migrations. Give it up for Sebastian.
Yeah, hello everyone. I'm going to talk a little bit about something that really bugs me, that I get to see a lot of in the real world. It's causing real problems, so it's not going to be funny, but it's going to be a little bit more serious. So we're here at Pycon, so I assume you all are way better programmers than I am. So you all write bug-free code, right? Or maybe not. I see a lot of smaller applications out there, mostly web applications, that don't test code that is directly touching production databases. And I'm here to convince you that you should do that otherwise. So, say that you have a small application, and that small application treats its database as a managed dependency. What that means is that your database is the only application that will ever talk to the database. It has a complete control over your database. If other applications will try to communicate to your database, they have to do it to an API or not at all. And every interaction your application has with the database is hidden from the outside world. So you could say that your database lies within the boundaries of your own application. Often in such a situation, your application defines the table structures or the schemas it needs in the database. And a migration tool like Lindberg or Django's migration system takes care of actually bringing about the structure of your database. But sometimes our migrations go a little bit further. You might want to change the contents of your database. You might want to add names together to get a full name column. You might want to change currencies. And when you do that, in Django, you write something called a data migration. And in a data migration, you write a little bit of Python code or a little bit of SQL code that performs the logic. And you can do very much the same with Alembic. Well, this is actual code you write. And this is actual code that you should test. Because it could have dramatic effects on your production data. And I really mean that. You don't want to lose customer data, you don't want to lose your scientific data that you so preciously and so expensively gained. So you should really test your data. And one thing that I hear a lot is that people say, well, I have rollback capabilities. If something goes wrong, I'll just roll back my database, roll back to migration, and I'm fine again. But that's not really the case. Because what the problem is that basically things working fine and things exploding are just two separate parts of your bug scale. And both situations are relatively benign. And you might be surprised when I say that things exploding is relatively okay, but then at least you know that things are not working. You can roll back. What is much more of an issue is that when you're in the middle of that landscape, when you're in the middle of that scale, that's where things get really tricky. You've executed something, but you might, and a migration works, but you might have actually messed up your data. For example, say that you actually accidentally truncate all the addresses of your customers, or only the long addresses. Your migration will work, but you will no longer be able to ship anything to your customers. If these distortions are massive, you detect them right away, you fix them, you go on. But if they're small, and they're often small, you might only notice them after months, and then you've been working with flawed data all along, and you cannot really fix it anymore. So the solution is to treat the code you write for those migrations as real code, and you should test it. Now, how can you do that? Well, you can write integration tests, because this is a managed dependency. And that's in the classicist way of thinking that's promoted in this book, for instance. And you should just test your migrations with a test database that's very much like your own production database. And you should do that. Now, how does that work? Well, it's actually very simple. You have a before state before your migration, and in your test, you should make sure that you migrate your test database to that state. You just dump test data into your database, then you run your migration, and then you assert that the result is what you want it to be. For Django, there's a very handy package. It's called Django Test Migrations. I didn't write it, but I use it a lot. You should definitely use that. There are some remarks. Use realistic data. Faker data often isn't good enough. It doesn't contain the edge cases. If there are edge cases that you are ignoring, please do make sure that you insert barriers, raise exceptions when they do occur in your production data. And finally, those tests can be really, really costly. They can cost a lot of time, so don't put them in your regular unit test suite. And before we go, we all love Pycon, but please support your local conferences. I'm a volunteer for EuroPython. Please go there, but also go to your local conferences. Thanks a lot. This was it.
Thank you, Sebastian. And next we have William, who's going to tell you all how to secure your PyPI account. Awesome. Give it up for William.
Hi, everybody. So this talk really only has 2 slides. So basically, this talks about how to secure your PyPI account. My name is William. This is the 1 slide. First, as a show of hands, how many of you have a package on PyPI? Okay, so like about half the room. So immediately, this talk immediately applies to you. But for a good other portion of you, you will probably end up publishing a package on PyPI at some point, or you might be a manager of a team where people on your team are publishing packages. So hopefully you'll have something to take away from this too. Basically what I'm going to demo is 3 main techniques you can use currently on PyPI to lock down and secure your account. We'll talk about enabling 2-factor, WebAuth and TOT or both, adding scoped API tokens for your projects, and also recovery codes. So without further ado, so I have a local copy of Warehouse here, which is the software that powers PyPI. And you'll notice that I am not actually eDurban, but I am logged in as them, and I will begin making some security changes. So if I go to Settings, you will see that I have the ability to add 2-factor for my account. There's a 2-factor requirement. In order to add 2-factor, I have to add recovery codes first. So I'm going to go ahead and generate some recovery codes. And to do this, it's going to ask me for my password, which, because this is a local setup, is password, which I then mistyped. Hello. 3rd time's a charm. OK. So it's going to ask you to save your recovery codes. I'm going to go ahead and not save them because it's a demo, but I'm going to copy one of them just in case, because it's going to ask me to enter one to make sure that I actually did save them, which I didn't do. So I am going to verify. It's now verified, right? And now it's going to let me do real 2-factor. So I have 2 options. I'm going to do both of them for you. I'm going to add 2-factor with an authentication application, also known as TOTP, and then I'll also do one with a security device, aka WebAuth token. So for 2-factor with a authentication application, it's going to give me a little QR code, and now you're going to have to trust me that I'm going to use one on my phone. You're not going to be able to verify this, but I'm going to go ahead and scan it. It's going to give me a little, 6-digit code. I'm going to go ahead and put that in so it can confirm that I haven't just deleted it again. So in this case, again, this does not matter that you can see it because this is going to get deleted as soon as I stop. But I have now added TOTP. And what this means is that the next time you log on to PyPI, it will prompt you for a code, basically, to ensure that you are, in fact, possessing the device that has the token. But we can go one step further, and we can actually add a security device, too. So go ahead and do that. Similarly, I'm going to go ahead and name it. So you might have multiple WebAuthn devices. So in this case, I'm going to call mine the laptop key, right? Click Setup. It's going to prompt me for permission. I'm going to do a security device. And I'm going to go ahead and touch it. And the security device is set up. So now, if you see at the bottom here, I have 2-factor authentication methods. I have my TOTP application, and I have my laptop key, security key. I can remove any of them at any time. And yeah, pretty much it. You can also see the security events. So on your account, if you log in, you'll see if someone has set one up for you on your behalf, perhaps without you knowing. Actually, just to demo this really quick, I'm going to go ahead and log out and log back in. So okay, with the device, touch my thing, and I'm logged in. So the one last thing I wanted to demo was API tokens. And so we've had API tokens for a couple years now, but one of the cool things you can do that not as many people know about is that you can scope them to individual projects. So I'm going to go ahead and add an API token. This is the standard API token view. And I'm going to name it, crap. And I'm going to scope it to clandestine D. So when I do this, again, this token is not actually secret, but in the real deployment, this would be a token that you would add to GitHub Actions or to your local workflow to publish. So you can use this instead of a password. It's much more secure. instead of copying your password everywhere. You can remove the token if that was a mistake. And you will note that doing all of this also corresponds to events on the page. So again, you can audit this. And that is all I have. So thank you.
Round of applause for William. And also, what William didn't say was he was the person that implemented a lot of this for PyPI. So let's give him another round of applause for that as well. All right. Next up, we have Alexa with generating recipes of varying quality with GTP2. Give it away for Alexa.
Hi, I'm Alexa, and today I want to talk to you about generating recipes with deep learning in Python. My main goal for this talk is just to show you that it's pretty easy, it doesn't have to be intimidating to get started with deep learning, excuse me. So this really only has 5 steps. I'll walk you through the whole thing. The first step is to get your model. Here I'm going to use GPT-2. There's a great package called GPT-2 Simple by Max Wolf on GitHub. I'll use that. It makes fine-tuning really easy, but you can use pretty much any language generation model that you like. Here's my code. It's pretty easy to load up GPT-2. I did this all in Google Colab. If you want more details about exactly how I loaded up this model, you can just search GPT-2 Simple, and all the documentation is online. Our second step is to prepare your data. So you can use any data set you like. I just took a data set right off of Kaggle. I took the CSV file, changed it to a text file, and added some little tokens to make sure my model knew where the start and the end of the recipe was, as well as where the different sections of the recipe were. So our third step is to fine-tune. Now, these language models that I'm using are pre-trained on a huge amount of data. All we're doing by fine-tuning is getting it to focus in on recipes specifically. So this GPT-2 Simple package makes it really, really easy. You can do it in one line. Fine-tune, and then the name of your training file. But you also have some options to customize. So you can change the number of steps that you train for. You can change how often you print, sample, and save data. And you can also use some memory saving options if you're running it in Colab like I was. Our fourth step is to choose good prompts. Don't overlook this step because it really makes a difference on how your model performs and how your output looks. So you can choose lots of options. You can prompt it with search terms or tags. You can give your model an ingredient list and ask it to generate a recipe from that. What I did was give it a recipe title. You can also use something called few-shot learning, which essentially just means you give, within your prompt, a few examples of your desired output. So for my case, that would look like giving a few complete examples of recipes that I would like it to generate, and then a title at the end of my prompt that tells it actually which recipe I would like it to generate. And that just gives it a better idea of what kind of structure and format I'm looking for. So our fifth step and last step is to actually generate our recipes. So you can choose to generate it just in your terminal or to a file. You can see here I have it going to Pycon recipes.txt. You can change your temperature, which is essentially how expected or unexpected you want your generated text to be. Here's where you load in your prompt. I asked it to truncate when it reaches this little end recipe tag. That will just tell us when it gets to the end of the recipe, or it thinks it's gotten to the end of a recipe. We'll see. And you can also change the length and the number of samples that you generate. So this talk would not be fun if I didn't get to show you a bad example of a recipe that I generated. So I wanted to show you this one for almost sugar-free vanilla fudge cake, which is really something. You can see it's got several issues. It's got the general structure down, but it's, there's some things to be improved there. My favorite part of this is when you look at the directions and it asks you to use an air conditioner as an appliance. Clearly, there's some improvement to be made here. If you want some better luck at home when you're doing this yourself, you can do things like include more training data, train for more steps, use few-shot learning, which we talked about earlier. It's just including examples of your desired output within your prompt. And also experiment with settings. Because it's a lightning talk, I can't really go deeper into the different settings that you can use and change. But definitely experiment with your models and see how it goes. If you want more info about the package that I used for this, here's a QR code. It's there on GitHub, but that's all. Thank you.
That was great. That cake looked delicious. My absolute favorite class of humor is like machines trying to be humans very badly. It's absolutely hilarious. Okay, next we have a talk on the dreaded Django upgrade by Srinivas. Let's give Srinivas a round of applause.
All right. Hello, everyone. I'm Srinivas Bontula. I'm a software engineer at Cox Automotive. And yeah, I mean, this is my first Pycon, and having a great experience. I hope you guys do. Yeah. One thing I wanted to share is it's one story sitting there and listening to the talks and enjoying them, and it's a totally different experience standing here and trying to talk. It's so fast, my heartbeat right now. All right. Without further ado, I'll go into the talk. So what I'm going to share with you today is about our story of upgrading Django from, like we were running it on 1.11.x version and then upgrading it to the latest version. I'm going to share it with you soon. And it's not reinventing the wheel. It's more like sharing our story so that some small fine-tuning and steps that we did to just get through the process faster. All right. Sorry. Yeah. All right. So why upgrade? Django, just like any other package or library, right? What happens is over the time, you won't receive the security hot patches and then the support for the latest versions or the latest transitive dependencies or libraries. And same with the features too. Like the older versions, they stop developing the features, just like any other library. And what we observed over time is when we developed our code, this was like 2015, 2016, and we never upgraded the Django version that we were running since then. So towards the end of 2020 and 2021, that's when we started noticing a lot of problems because of this. All right. So just as I said earlier, right, we were running on Django 1.11.18, and then if you look at the slide there, that shows the end of cycle for the Django versions. It's not even visible in that. So it sort of ended even before 2019. So now you know why we had to do that. We were forced to do that, but we are glad we did the upgrade because right now, you get the throughput, the runtime, or the processing time in the application, not even going to the database level, but the application itself is fast. And this applies, so just to give an example, our system is more like monolith and tied up with the microservices, but this sort of works with, the approach that we took works with any repository, smaller code repository, thousands of lines of code or million lines of code, et cetera, et cetera. All right. Okay. The first thing is, I think, the problem that most of us face is about dependencies, be it direct dependencies or transitive that we see in the packages. That is our inbuilt packages or open source packages that we pull into our system. And one thing that we sort of did it as a precursor before even moving into the upgrade is making sure we have the dependency either pinned or unpinned depending on what we need. Like pinning the pinned dependencies, obviously everyone prefers that because you know that even with the upgrade, and when you do the pip compile, it's going to just install the same package, so your code would run without any errors. But there is a problem there in the sense that you won't get the latest packages. So Django, we know we are getting the latest package, but not the other libraries. So at some point, you got to either unpin them or define a specific version that works for you. And then now coming to unpinned. Now so for us, as I said, it's a monolith tied to different microservices. So we made sure that the setup.py, that the installation files for all the microservices, you would never touch or you would never pin any dependencies because when you're pulling it into the monolith, you would want to pull the latest versions for it to run without any errors so that the transitive dependencies are upgraded. All right, moving on. And another small thing that sort of helped us move quicker is annotating the pip compile. By that, I mean, if you look at the hashes on the side, you would know the exact dependencies for packages in your output requirements.log. What that helped us in doing is when you are manually installing or deleting a package, you would know what transitive dependencies to remove even before the pip compile step. So that sort of helped us move quicker. And then just going to the Django itself has great documentation. So like just reading the release notes or how to do the upgrade or the deprecated methods, the most important thing would give you more information on what to address quickly. And then we have a lot of open source code modders, I would call them, which is like automatic, it's easy to fix the deprecations in your code. These are not written by us, these are open source libraries that we have. Oops.
Oh, we're at time.
Oh, out of time.
One
No
second,
worries.
go ahead, go. Finish it
Yeah,
up. Wrap it up.
this is the last slide, so I just wanted to say these are the open source libraries that help you fix the deprecations in the code automatically.
Round of applause.
Yeah. Thank you. Thank you.
I had one job. All right, and I think for our last talk, we're going to have Adrian, who's going to talk to us about when to rewrite in Rust. Let's give Adrian a round of applause.
Hello. Hi, folks. My name's Adrian. So I rewrote a module in the standard library called GraphLib. It's available in 3.9 in Rust. In this talk, I'm going to talk about what I learned from that. It was my first time moving something to Rust. Maybe when you should rewrite something in Rust. So the first thing I want to talk about is when is it good to rewrite something in Rust, or like when you should think about that. I think especially if it's your first time doing it, you should pick something that's CPU bound, that's a well-contained MPI, and ideally has existing tests. So something like GraphLib, which is an existing, well-understood piece of Python, is a good candidate for that. If it's your first time trying to write something in Rust, maybe trying to figure out how to test it, how to learn Rust, all that in one go, and figure out the API for your thing is probably a little bit too much. So the next couple slides are going to be interesting things that I learned from my first time writing something in Rust. So the first one is the idea of fallibility. In Python, you can raise an exception anywhere. In Rust, you can't do that. And in particular, for something like graph-related, in this case, it made sense to represent as like a hash map sort of thing. And there's many ways to represent a graph, but in this case, that's what made sense. And the issue encountered is that Python's hash function is fallible. You can raise an exception, like there's things that are not hashable. But Rust doesn't allow that. And what happens if you try and do that is you just get like a panic and like everything's pretty ugly. So the way I solved this problem is I just created like a little struct. This is Python, but really this was written in Rust. It's just so we can all understand it. And what I do is I hash the thing before I put it in here, and so now my hash function is just returning a known value. And that means that when I call Python's hash function, I'm still at a point where I have control and I can return a Python error, as opposed to Rust's hash function calling it where there's no error handling. The next is boundary crossing. One of the more expensive things, especially for the current state of Rust Python bindings, is doing a lot of calling from one place to the other. So when you're designing, really even at the API level, you want to minimize how much you're going to have to call Python from Rust and Rust from Python, because if you're doing that all the time, it's going to be slower than if you just did it in Python. And the issue I encountered was when you have a hash map and you find that something has the same hash, so maybe it's the same thing, maybe it's the thing you're looking for, then you still need to do an equality comparison to make sure it actually is the same thing. And that meant that every time I looked something up in a hash map, I had to call back into Python. And that was really slow. So I did a little optimization. Python does this already, but what I did is I just did a reference comparison in Rust before calling to Python. And so for most cases, when you're saying, with this API, you're saying this task is done, that task exists in the hash map, and it's the exact same object, and so this means that I almost never have to call back into Python. The last more interesting one is mutability. Rust has this whole borrow system, and one of the fundamental rules is you can't have more than one mutable reference. In Python, everything's kind of mutable reference, but you can't, like grab a value in a dictionary and then mutate that and then use that to look up something else. You run into issues. And the existing API for GraphLib is something like this. There's like a class that contains information on each node, and it has some mutable parts, like whether the thing is ready or not, and some parts that really aren't mutable, like the parents of that task. And so what I had to do is I had to destructure that into two different things. So I had to have like a mutable part and an immutable part, and that allowed me to freely access the mutable part, and then access the mutable part, return the reference, and then move on. So you can see there's some issues with this. The Python version, in my opinion, is a lot nicer. Everything's contained in one place. Here you can end up with like different keys and mappings. It gets weird, but that's what you have to do. And so my takeaways for this are probably write it in Python first. Don't, understand the API, understand where the hot loops are, understand where you can gain performance before you move to Rust. And once you are writing in Rust, think about boundary crossing, try and minimize your calling back and forth, try and move work to Rust, do work in Rust, then come back to Python. And think about fallibility. That's something we don't really think about in Python. Anything can raise an exception. In Rust, you don't really have that luxury. You have to be more explicit, and sometimes you can't even raise an exception. And then make things immutable as much as possible, because that's going to make it a lot easier to work with the borrow checker. And so the last question is probably, was this fast? Yes, it was very fast, and it worked great.
And that wraps it up for today's lightning talks. If you want to watch more lightning talks, we'll be back at it again tomorrow morning before the keynotes at 8 a.m. Come back here, come and see us. We'd love to have you. Take care and have a good night.